Hi, I'm Brennan from Makepath, and the following video is a companion video for a recent blog post that we did, which will go a little deeper into the analysis side of a piece that we did on pharmacy deserts. This recent blog post about pharmacy deserts, which are locations with reduced access to pharmacy services, highlights the use of open source tools like Xarray Spatial and Datashader in gaining insight into a real world problem. Senior citizens are a group that are particularly vulnerable to pharmacy deserts because they disproportionately use those services. So in this blog post, we looked at pharmacy deserts and counties which had particularly high plus 65 populations. So you can read through the post and definitely tell us what you think in the comments, but let's open up the companion notebook and walk through the analysis. To find the companion notebook, you can scroll down to the bottom of the blog post and click on the full analysis link, which is going to bring you over to a Jupyter notebook on GitHub. This is inside of Xarray Spatial's examples and uses Xarray Spatial, which is an open source raster analysis library. So in this analysis, we start by importing some tools. We import Datashader and NumPy, Pandas, GeoPandas, and Xarray Spatial. And we start to load up our source data. So we got pharmacy locations from the Department of Homeland Security. We're going to load up that CSV as a Pandas data frame, do a little bit of munging, load up block groups as a shapefile using GeoPandas. And we're using Spatial Pandas, which is an additional spatial feature for Pandas, which allows Datashader to rasterize polygons. We're going to take the sum of 3 of our population demographics fields. This will allow us to then calculate a percentage above 65, which will help us target census block groups, which have particularly high percentages of above 65 residents. Finally, for analysis, we're going to summarize by county. So we're going to load up a county's shapefile, and we're going to identify different zone IDs, because in the end, we're going to do some zonal statistics. To start our analysis, we're going to define our study area, which is just going to be the lower 48 United States. We use Datashader to create a canvas. This canvas contains our height and width and our bounds in data space, which gives us our resolution. All of our data is going to be aggregated into this same canvas, and we're going to aggregate that data based on the geometry type. So in starting with just polygons, I'm actually going to rasterize just the counties, and that's going to become a mask. I'm using the Datashader shade function to then make that mask gray. And here we see that mask of the lower 48. Using that same canvas, we can align all of our data into the same resolution. So next I'm going to actually add in the pharmacy points by using our same canvas and the points geometry. That gives us a pharmacy raster. And we can use Xarray Spatial's proximity tool to then create a great circle distance grid. This will give us the distance to the nearest pharmacy for each one of the pixels in our output raster. That gives us a continuous distance, but I want to classify this distance into 5 different groups. I'm going to use the natural breaks or Jenks method to do that. And what that's going to do is it's going to look at all the distances in the raster, and it's going to group them into 5 different groups, which minimize their standard deviations. And that's just how natural breaks works. But when we shade this layer with an Inferno color map, we're going to see that we have 5 different colors, and they represent our 5 zones, and they can help us in starting to identify what are pharmacy deserts. Now, I didn't use someone else's definition of a pharmacy desert. I'm more just exploring the data, and for my purposes, I think we're going to classify anything that's in the farthest distance group as being a pharmacy desert, as a simple definition. I'm going to do something similar with the block groups. So this is block group geometry. I'm going to use my canvas and polygons to rasterize the block groups. And then the values are going to be the mean of the percent over 65 for each pixel. So if, for some reason, if 2 vertices from neighboring polygons fall into the same pixel, then we'll take the mean of their percentage above 65 to put that in our output raster. I'm going to use the same natural breaks method to classify this percent above 65 raster into 5 groups, also minimizing for standard deviation in each group. So now with distance from pharmacies and percent above 65, I'm getting close to being able to identify some pharmacy deserts of interest for me, which for my question, it was related to pharmacy deserts in counties and block groups that have particularly high percentages of plus 65 residents. And here I'm using Xarray Spatial's binary tool to classify each one of the images into either a 0 or a 1, depending on whether it is a value in my pharmacy desert question. So I'm going to say I'm only going to grab values that are in the highest category of distance and the highest category of percent above 65. Combining these together, we drop out a lot of the areas, and we can see only the locations that have particularly high above 65 residents and distance from pharmacies. And then in the next step, we're going to summarize this output by county so that we can tally up the stats for each county and how they relate to our pharmacy deserts. There, we're going to use Xarray Spatial Zonal Stats tool. And this Zonal Stats tool takes a set of functions to run. And in this case, I'm going to create a zonal function called pharmacy desert mean. And it's going to look at all the pixels in that zone, and it's just going to take the mean value. So if the zone was completely pharmacy desert, we would expect a value of 1. If it had no pharmacy desert, we would get 0. So once we summarize our pharmacy desert raster by our county raster, we get a pandas data frame back that shows our top 10 pharmacy desert counties. And this helped us then contact people that may know more, that either run senior citizen programs in those counties to understand more about this topic. This helped us then learn more and go deeper. And as we made calls to some folks in these counties, they told us more about the pharmacy desert situation in their neighborhood. And finally, these are those counties highlighted on the map in red. So we use Datashader and Xarray Spatial to explore this idea of pharmacy deserts. Tell us what you think. Visit the blog. Let us know if you have any interesting ideas on what we could do next. Thanks so much.